polymerization reactions. There are three types of polymerization reactions. The first one, addition polymerization reaction, also known as chain polymerization or chain growth polymerization. And second one, condensation polymerization reaction, which is also known as step growth polymerization reaction. Third one is copolymerization reaction. Now, addition polymerization. This addition polymerization reaction yields an exact multiple of the original monomeric molecule. When we compare the molecular weights of all the monomers reactants, taken in the all the monomers taken in the reactants, and the molecular weight of the polymer, both are equal. So polymer is a exact multiple of all the monomers. Such a reaction is called addition polymerization reaction. It is instigated by either heat, light, pressure, or any catalyst. Here this is the example, ethylene monomer. Ethylene monomer, on heating or by using any peroxide catalyst, we can break this double bond and it is become a bifunctional molecule and undergo polymerization to yield the polyethylene here. So that is the reason the polymer is a exact multiple of the monomeric molecules. So already we have discussed, if the monomer is containing double bonds, two or more, they undergo rearrangement to make the molecule become bifunctional. Addition polymerization generally occurs between the monomers having the double bonds. And here we can break this double bond either by heating or by passing the light, or so passing the light means it is a photochemical reaction, and by applying pressure or any catalyst like hydrogen peroxide or benzyl peroxide, etc. Next, condensation polymerization. So from the condensation we can understand elimination. Condensation means elimination. Here this type of reaction occurs between the monomers containing the simple polar functional groups. Simple polar functional groups like carboxylic group, acid chloride group, amide group, alcohol group, amine group. So such monomers, they combine to form a polymer by eliminating the small molecules like water, hydrochloric acid. Here we see one example, nylon 6,6 preparation. Here two monomers, that is hexamethylene diamine. Here we can see this is one amine unit and this is another amine unit, and one more monomer, that is adipic acid. Adipic acid is a dicarboxylic acid. Here you can see two carboxylic acid functional groups. Now this amine group and carboxylic acid groups combine by eliminating the small molecule water. So here elimination of the water molecule, you can see H2O is eliminated in this reaction and will form a amide bond. We call peptide bond also. So amide bond, in this way this hydroxyl group is eliminated, and also this hydrogen also eliminated and attached to the adjacent carboxyl group, and hydroxyl group also adjusted to hydroxyl group is eliminated and that is attached to the adjacent amine group. In this way a condensation polymerization occurs. So condensation polymerization is nothing but it always proceeds by the elimination of small molecules like water or HCl, like any alcohol like methanol and ammonia, etc. Small molecules are eliminated in this reaction, and this type of reaction occurs between the monomers having polar functional groups. So these polar functional groups must have affinity towards each other. Next, if we compare this, or if we distinguish the addition and condensation polymerization reactions, so this is very important here. Addition polymerization reactions undergo self addition, and there is no loss of any products, whereas in condensation reaction we can observe the elimination of the small molecules like water, ammonia, hydrochloric acid, and here these monomers are containing the polar functional groups. And addition polymerization reaction follows the chain mechanism, and condensation reaction follows the step growth mechanism. Mostly unsaturated means vinyl compounds. Monomers having the double bonds undergo addition polymerization reaction, and condensation reaction occurs between the monomers containing the functional groups like polar functional group like hydroxy group, carboxylic groups, amine group, etc. Now, here monomers are linked together through carbon-carbon covalent bond linkages, whereas the polar functional groups, they may be linked, the covalent linkage may be formed between carbon-carbon or any hetero atoms. Next, high polymers. High polymers are formed by the addition polymerization, and it is a fast reaction. Next, in case of condensation polymerization, the reaction is slow. Molecular weight increases steadily throughout the reaction. Linear polymers are formed by this addition polymerization, and there is no branching because only double bonds we have, whereas in condensation polymerization linear or cross-linked polymers are obtained. And examples, and polystyrenes, plexiglass, polyvinyl chloride, Teflon, etc. they are formed by the addition polymerization reaction, whereas nylons, terylene, polyesters and phenol formaldehyde resins, they are formed by the condensation polymerization reaction. Next, the last type, that is copolymerization. Copolymerization, we know copolymer is nothing but formed by the monomer. Copolymer contains the monomers of two or more monomers of different chemical structure. They are not identical, different chemical structure. Here it is the joint polymerization of two or more monomeric species. In this copolymerization reaction, we observe the high molecular weight compounds are obtained. High molecular weight polymers are formed by the copolymerization reaction. The best example is preparation of the Buna S rubber. Styrene butadiene copolymer rubber. Here 1,3-butadiene is a one monomer, styrene is a one another monomer. Two monomers having different chemical structure undergo polymerization reaction. We call it as a copolymerization because it yields the copolymer. Now the copolymer, here one butadiene copolymer, butadiene and styrene, they form a long chain polymer. So this polymer chain contains two different monomers of different chemical structure. It is a copolymer. Next, and we discuss the mechanism of polymerization, that is only free radical polymerization. This free radical polymerization is a basis for the addition polymerization reaction. So the entire addition polymerization we can explain based on the free radical mechanism only. Here we can divide three steps, or this free radical mechanism involves the three steps. The first step is initiation, the reaction first initiated, and next chain propagation, and at the end chain termination reactions. First, initiation. So initiation, any initiator we take here, and this initiator may be any monomer, any peroxide, and here this initiator will be excited to form or will be broken to form a free radical either by subjecting to the heat or light. Now, so formed free radical. This free radical combines with our monomer. Here we have one example, halide or vinyl monomer, we can say. Here this radical is attached to the vinyl monomer and forms a new free radical, and this free radical involves in the chain growth or chain elongation reaction, which we call as a propagation step. Here these new free radicals attack on monomer molecules, fresh monomer molecules, and that will form another new free radical, and further in quick succession leading to the chain propagation. So one by one, turn by turn, first this free radical combines with the another fresh monomer of vinyl monomer, fresh vinyl monomer. See, and once new free radical is generated, again it combines with the fresh vinyl monomer and new free radical is generated. In this way the chain elongation takes place. Suppose if we take it is mth stage, m times it is taking place, at the end we obtain a polymer which is having m-1 monomers free radical. And the last step, termination, chain termination reaction. Here the chain termination can be done by in two methods, either by coupling the two radical chains or by disproportionation reaction. So coupling, two radicals come together and will form a long chain. This is one radical and this is one radical chain, and they combine to form a saturated long chain polymer. This is coupling, combining together of two radical chains. And disproportionation means here they transfer the hydrogen from one radical to another radical. A hydrogen is shifted. Here this is one radical and this is one radical. Here hydrogen is transferred. This hydrogen is transferred to the, see, transfer from here to here, this radical, and here we obtain the two different polymer chains. This is one polymer chain and here one unsaturated polymer chain is obtained. It is called disproportionation reaction, which occurs by transfer of hydrogen.